Hello everyone, welcome to the course on operating systems. In this session, we'll be discussing about different types of operating systems. So in our daily activities, we'll be using so many types of operating systems, including Windows, Linux, Unix, Android OS, iOS, Mac OS. Like that, there are several different operating systems that are existing. And why these many operating systems are required? Now let us understand the need of having so many operating systems. So if you look at the different devices like desktop PC or the mobile device or tablet PC, they have different hardware specifications and they have different processing powers also. So for example, if you look at the mobile device, the processing power of mobile is relatively less as compared to the desktop PC. On the other hand, it offers portability and mobility. Like that, different devices are designed for a specific purpose. So their computational speeds vary significantly. And if you look at different types of applications, like real-time applications, which includes aviation or healthcare or robotics, where the real-time data is being collected and processed. And in such a case, whatever the operating system that is being used for desktop PC is not suitable for this type of real-time applications. So there is a diversity of applications and there is a diversity of hardware specifications of the devices. So in addition to these two, there is a technological evolution because of which the new operating systems have been evolved. Now let us understand the different types of operating systems that have been evolved since the beginning, including the batch operating system, multi-programming operating system, multi-processing operating system, multitasking, time sharing, distributed operating system, network operating system, and real-time operating system. So these are the different types of operating systems that have been evolved ever since the computers have been developed. Now let us understand how these operating systems work and what are the advantages and drawbacks of all these operating systems one after the other. So in this session, we'll be discussing about the first 4 types of operating systems. And in the next session, we'll be discussing the remaining 4 operating systems. Let us start with the batch operating system. So batch operating system was the olden operating system where users, they used to use punch cards for submitting their jobs. So if they have to execute a program, they used to use the punch cards and they'll be submitting those punch cards and which are called as jobs. So if there are n number of users, they'll be submitting n number of jobs and these jobs are categorized into batches based on their resource requirement. That means jobs which needs to be printed. Let us understand that jobs which needs to be printed, they are categorized as batch 1 and jobs which need the CPU computation are categorized into batch 2. Like that, depending upon what kind of resources these jobs require, they are categorized into batches. That means jobs having similar resource requirement are categorized into one batch. And then each batch is submitted for execution to the CPU. And the CPU used to execute these jobs one after the other. So such kind of operating system is called as batch operating system. Now let us understand what are the advantages and drawbacks of these batch operating systems. Since jobs are categorized into batches based on their resource requirement, so it makes use of resources more efficiently. So efficient for repetitive and resource intensive tasks. So in such a case, the resources need not be shared by any other jobs or jobs belonging to a different batch. So since jobs of each batch are requiring similar resources, those resources can be dedicated to executing these jobs one after the other. And the drawbacks include minimal user interaction. So here if you look at the user intervention, users simply submit their jobs, and there exists an operator who is responsible for categorizing these jobs into batches. That means operator groups the jobs into batches based on the resource requirement. And once the user submits the jobs, there is no more interaction by the user with the job execution. He cannot understand what is happening to his jobs until and unless he receives the output of his job. And it requires an additional entity called as an operator who is responsible for grouping of jobs into batches. And one more drawback is longer waiting time. That means if at all a job belonging to the second batch, it has to wait till all the jobs of batch 1 are executed. So that means batches that require a different kind of resources have to wait till the jobs that require the resources or the jobs of batch 1 are executed. So which leads to longer waiting time. And examples of batch operating systems include IBM OS 360 and mainframe computers. Now let us see another kind of operating system, which is multi-programming operating system. So if you look at the batch operating system, CPU executes only one program at a time. That means there exists only one program in main memory. But when the program has to perform an IO operation, in such a case, then the CPU has to remain idle. That means if you allow only one program to be in main memory, which is to be executed by the CPU, what if that particular program requires an IO operation? If you compare the speeds of CPU and IO, CPU is much faster as compared to the IO devices. That means whenever a program is performing an IO operation, CPU has to wait. So CPU remains idle. So in operating systems, keeping the CPU busy all the time is the most important in order to achieve higher CPU utilization or high performance. So once we see the CPU remaining idle, that means the efficiency is reduced. So that is the case in case of batch operating systems. But this problem is solved by the multi-programming operating system. Now let us understand the multi-programming operating system. So in multi-programming operating system, not one single program, but there exists multiple programs in the main memory. So whenever a program is being executed by the CPU, it will be utilizing the CPU, and whenever a program is performing an IO operation, in such a case, the CPU is allotted to another process. For example, here if you look at this diagram, initially P1 is executed by the CPU, and once P1 has to perform certain IO operation, or it has to write something onto the hard disk, in such a case, instead of making the CPU to wait, CPU is allotted to the program P2 or the process P2. And P3 and P4 are waiting for their turn to gain the CPU. So this kind of operating system is called as multi-programming operating system. That means you are not keeping the CPU idle whenever a program is performing an IO operation. Instead, the CPU is allotted to the next process in the queue. Now let us see the advantages and drawbacks of a multi-programming operating system. CPU idle time is reduced because it is allotted to some other process whenever the current process is performing an IO operation. So we are increasing the CPU utilization. And it needs lesser waiting times because whenever P1 is executing an IO operation, CPU is not kept idle. Instead, it is allotted to the next process. So obviously, the waiting time of the next process is reduced. And the drawbacks include, since we have to bring so many processes to the main memory, it introduces complexity. and it requires CPU scheduling algorithms. CPU scheduling algorithm means to determining which program or which process has to be allotted the CPU. That is called as scheduling of the CPU. And it needs more memory management techniques also, because the main memory is allotted to multiple processes, not just to one process. So whatever the currently executing process, they have to occupy the main memory space. So whenever the main memory is full and a program has to be brought to the main memory, in such a case, there should be some mechanism of moving the process that are in the waiting state to the hard disk. So such mechanisms are called as memory management techniques. And examples of multi-programming operating systems include all the modern operating systems, including Unix, Linux, Windows, Mac OS, iOS, Android. All these support multi-programming. And the next type of operating system is multi-processing operating system. So here there exist multiple processors or multiple cores, multiple CPU cores. So multiple processing systems are computer systems that utilize multiple processors or CPU cores to execute tasks concurrently. So if you look at the diagram, there exists multiple CPU cores, CPU1, CPU2, CPU3 up to CPU-N, which are sharing the same main memory or RAM, and they are connected to multiple IO devices. So here, instead of having the process executed by one single CPU, there exists multiple number of CPUs available for executing the programs. So such kind of operating system is called as multi-processing operating system. Now let us see the advantages. Because multiple processors are there, or multiple CPUs are there, the number of processes will be distributed among these CPUs. So which results in parallel processing. So the speed of execution of the programs will be increased, and increased throughput. That means the number of processes executed per unit time is called as the throughput. Since there are more number of CPUs, obviously there can be more number of processes executed per unit time. So that way we are increasing the throughput. And this kind of operating system is more reliable. That means even if one CPU fails, there exists another set of CPUs to take care of the execution of the currently running processes. And coming to the disadvantages, this kind of operating system is more complex because there exists a complexity of managing multiple CPUs, and sharing the main memory across multiple CPUs introduces complexity. And it is more expensive because of more computational power. It is more expensive. And synchronization overhead. If there exists process that have interdependency, in such a case, synchronization between the execution of the process by the different CPUs is an additional overhead. Examples of multiprocessing operating systems include Linux, Windows Server, Mac OS. So these are the examples of multiprocessing operating systems. Coming to the next one, multitasking operating system. It allows multiple tasks or processes to run concurrently on a single computer system. In our whenever we use computer, we'll be opening the browser, and we'll be opening some other browser for checking the mails, and we'll be using some MS Office for editing the documents or for preparing the PowerPoint presentation. And at the same time, we'll be using some Paint for editing the images. So we are able to execute multiple applications at the same time. That means we are able to execute multiple tasks concurrently. So that kind of ability provided by the operating system is called as multitasking capability. So it allows multiple tasks or processes to run concurrently on a single computer system. And how this is achieved? Because at any given point of time, CPU can execute only one process, but we are able to execute so many processes. How is it possible? So it is possible because the CPU is made to switch between different applications so rapidly that as a user will not be able to perceive the switching of the CPU among different applications. So it gives an illusion to the user as if he is able to use all the applications concurrently. So in multitasking operating system, CPU switches rapidly between different tasks, giving the appearance that multiple tasks are running simultaneously. Now let us look at the advantages and drawbacks of multitasking operating system. It increases the user experience, it enhances the user experience, because if we are browsing, then we need not switch, or we need not close the browser and open the email again, or whenever we are going through our emails, we need not close in order to edit our document. We are able to do all these tasks parallelly, so it enhances the user experience. Improved efficiency, and it maximizes CPU utilization, because CPU is switching between multiple processes in order to provide multitasking appearance to the in order to perform multitasking and to enhance the user experience. So that way the CPU utilization is increased. That means CPU is not remaining idle at any given point of time. And the drawbacks of multitasking operating system include managing multiple tasks concurrently adds complexity to the operating system. So whenever the CPU switches from one process to another process, there exists a context switch. That means it has to save the current context of the currently running process, and then it has to switch to the next process. So this context switching by this CPU introduces complexity to the operating system. And one more drawback is resource contention. That means resource contention can occur when multiple tasks compete for the same set of resources. That means if at all multiple applications are trying to access the same resource, which is a printer or the keyboard, in such a case, we say that there is a resource contention. And whenever there is a resource contention, it has to be resolved so as to ensure smooth functioning of this multitasking operating system. And examples of multitasking operating system include Ubuntu, Fedora, iOS, Windows, and Android. So all the modern operating systems support multitasking capability. So in this session, we have discussed about the 4 different types of operating systems, including the batch operating system, multi-programming operating system, multi-processing operating system, and multitasking operating system. We'll be discussing about the remaining 4 types of operating systems in the next session. Thank you.